In the previous two videos, we've talked about how to, what a difference quotient is. So we first looked at the one here where we labeled our points as x, f of x, and x plus h, f of x plus h. And then the second one was when we labeled them as x and a. And so what we want to look at now is actually computing these difference quotients. So we know what they are. How do we actually compute them for a given function? So they're going to tell you in the problem which one of the two forms they want you to compute the distance quotient in. So here we're doing the f of x plus h minus f of x over h form. And our function here is x cubed. So the first thing we do is we write down the difference quotient formula that we're asked to use. So f of x plus h minus f of x all over h. And then we need to just evaluate what is f of x plus h. Well, that means we want to go into the f function, replace the x variable with what's on the inside, which in this case is x plus h. So that'll be x plus h to the third minus f of x, which is x to the third, and then that's all over h. Now, to compute x plus h to the third, you might recall in the past learning something called the Binomial Theorem. If you do remember that and how to use it, you could use that. Otherwise, you would need to multiply out x plus h times x plus h times x plus h. Now, I'm going to save us a little bit of time and tell you what happens when you multiply those out. You will get x cubed plus 3x squared h plus 3xh squared plus h cubed, and of course that's still minus the x cubed, and it's all over h. Now from here we can notice that I can cross out, subtract off, cancel out the x cubes, and they're completely gone. And then there's a little bit more simplifying that can be done, because notice of the three remaining terms, all of them have h as a common factor. And so I can factor that common factor out. And then it's still all over h. And then I can divide the h's out and get my answer, which in this case would be 3x squared plus 3xh plus h squared. That's a formula that will tell us the slope of the secant line if we know the x value and we know how far away from it we're going for our second point. In other words, the distance we're going away, h, whether h is positive or negative. So in this example, let's say we want to find the slope of the secant line when x is 1, and we're looking at a distance 1 away from x. So the other point is x equals 2. So we're finding the slope of the secant line on the x cubed graph from x equals 1 and x equals 2. And so we just plug those numbers in, and that will tell us the slope of the secant line. So the slope of the line there is 7. So again, we're going to be using these difference quotients later to define something called the derivative. For now, we just want to kind of introduce them and see how to compute them. So in the next video, we'll look at doing the other type of difference quotient, the f of x minus f of a over x minus a.